Have you ever looked up at the night sky and wondered about the stars? Ancient Greek philosophers did too. They were some of the first to try and understand the universe using reason and observation. Aristotle, a famous philosopher, believed that everything in the universe was made of four elements: earth, air, fire, and water. He thought the earth was the center of everything, and the sun, moon, and stars all revolved around us. While Aristotle got a lot wrong, his ideas were very influential and formed the basis of scientific thought for centuries. It's important to remember that in science, even being wrong can be a stepping stone to new discoveries. Fast forward many centuries, and a new era of scientific discovery was dawning in Europe, the Renaissance. During this time, thinkers began to question old ideas and make observations that challenged Aristotle's theories. One of the most important figures of this period was Galileo Galilei. Galileo used a new invention, the telescope, to study the night sky in ways nobody had before. He made groundbreaking discoveries, like the fact that Jupiter had moons orbiting it. This challenged the idea that everything revolved around the Earth. Galileo's work, alongside other Renaissance thinkers, helped shift our understanding of the universe and paved the way for a new era of physics. Perhaps you've heard the story of an apple falling from a tree and inspiring one of the most famous scientific theories ever. That's the story of Isaac Newton and his law of universal gravitation. Newton, a brilliant English physicist and mathematician, realized that the same force that pulls an apple to the ground also governs the motion of planets and stars. Pretty amazing, right? Newton's work revolutionized our understanding of gravity and laid the foundation for classical physics. His laws of motion are still used today to describe how objects move, from cars to rockets. For centuries, light remained a mystery. What was it made of? How did it travel so fast? Enter James Clerk Maxwell, a Scottish physicist who developed a set of equations that describe the behavior of electricity, magnetism, and, surprisingly, light. Maxwell's equations showed that light is an electromagnetic wave, a disturbance in electric and magnetic fields that can travel through the vacuum of space. This was a huge breakthrough, but the story of light doesn't end there. It was about to take a very strange turn. As scientists delved deeper into the world of atoms and light, they stumbled upon some very strange phenomena. It seemed that the laws of classical physics, so successful in explaining the everyday world, broke down at the subatomic level. Enter Albert Einstein, perhaps the most famous scientist of all time. Einstein proposed the theory of relativity, which revolutionized our understanding of space, time, and gravity. He showed that these concepts were not absolute, but were intertwined in a mind-bending cosmic dance. One of the most famous consequences of Einstein's theory is the idea that nothing can travel faster than light. This had profound implications for our understanding of the universe and opened up new avenues of research in cosmology and astrophysics. While Einstein was revolutionizing our understanding of the cosmos on a grand scale, other physicists were busy exploring the strange world of quantum mechanics. This new theory sought to explain the behavior of matter and energy at the atomic and subatomic levels. One of the key principles of quantum mechanics is the idea that energy exists in discrete packets called quanta. This means that energy, like light, can behave as both a wave and a particle, a concept known as wave-particle duality. Quantum mechanics introduced a new element of randomness and uncertainty into physics. It suggests that at the subatomic level, things don't happen in a predictable, deterministic way. Over the years, physicists have developed a framework called the Standard Model to explain the fundamental building blocks of matter and the forces that govern their interactions. This model describes a universe made up of tiny particles like quarks, leptons, and bosons. The Standard Model has been incredibly successful in explaining a wide range of phenomena, from the behavior of subatomic particles to the fusion reactions that power the sun. But it's not the whole story. There are still many mysteries that the Standard Model cannot explain, such as the existence of dark matter and dark energy, the nature of gravity at the quantum level, and the universe's imbalance between matter and antimatter. One of the biggest challenges in modern physics is finding a way to unify all the fundamental forces of nature into a single, elegant theory. This so-called theory of everything would bridge the gap between Einstein's general relativity, which describes gravity, and quantum mechanics, which describes the other three fundamental forces. While a complete theory of everything remains elusive, physicists are making progress. String theory, for example, proposes that the fundamental building blocks of the universe are not point-like particles, but rather tiny vibrating strings of energy. Another promising approach is loop quantum gravity, which suggests that space and time are not continuous, but are made up of tiny indivisible chunks or loops. The study of physics is a never-ending quest to understand the fundamental nature of the universe. As we delve deeper into the mysteries of the cosmos, we are sure to encounter even more surprises and challenges. What will the future of physics hold? Will we finally unlock the secrets of dark matter and dark energy? Will we find a way to unify general relativity and quantum mechanics? Will we discover new particles and forces that challenge our current understanding of the universe? Only time will tell. But one thing is certain: the journey of discovery in physics is far from over. There are still many mysteries out there waiting to be unraveled, and it's up to the next generation of curious minds to explore them. Thank you for visiting Physics Around Us. Don't forget to subscribe and write your comments below.